Example number 4, highlighting learning target number 1.2D. Into what set of real numbers should the result of multiplying 6.25 and pi be categorized? Consider the question and hit pause and work through the example. And once you've completed, restart the recording and we will work through the example together. So to approach this question, we can break it down into smaller steps, considering each piece individually. And in this case, our individual pieces are our numbers being multiplied. So we have 6.25 and we have pi being multiplied. And then we're also going to have a resulting product. Remember, product implies multiplication. And so to work through this example, we can see that we have to classify each of the individual parts into set classifications. And set classifications of real numbers are natural numbers, whole numbers, integers, rational, and irrational numbers. And so thinking about 6.25, we see that it is a decimal, and decimals are categorized as either rational or irrational numbers. And the definition of a rational number is a decimal or a fraction written in decimal form that either terminates or repeats. And so looking at 6.25, we can quickly conclude that the 0.25, let's clear that off so we can, that the 0.25 terminates. The decimal does not continue. It stops at the 5, the 0.25. It stops. And so because it is a terminating decimal, we can conclude that 0.625 is a rational number. Now, also included in that definition of a rational number is a repeating decimal. And we do know that 0.25 is not a repeating decimal, but a rational number does include both types of decimals. So either a repeating decimal or what we have in this case, a terminating decimal. So that is the set classification of 6.25. Now, the set classification of pi. Well, pi in its current form is not written as a decimal. And so if we were to convert pi into a decimal form, we would see that the decimal form is 3.14,159,265,8,5,8,9,3, and I could continue on forever. I'm just going to stop there. And so looking at the set classification, again, we can narrow our categories to either rational or irrational numbers. Rational numbers, once again, were either terminating or repeating decimals. And so looking at pi, we know that it is not terminating. It goes on forever. So now we need to determine, does it have a discernible repeating pattern within the decimal portion? So if I were to look at the decimal portion, is there a discernible repeating pattern? And in this case, it does not. There is not a terminating or a repeating pattern. So this is non-terminating, and it is non-repeating. And since it is a non-terminating, non-repeating decimal, our conclusion is that we are working with an irrational number. And so we can classify pi as an irrational number. Now we need to consider the product of 6.25 and pi. As a quick reminder, product implies multiplying or multiplication. And so when 6.25 and pi are multiplied, the resulting product is 19.63495408493621 and continues forever. And so in this particular case, we can see that once again we have to look at the properties of the decimal portion to determine if we're working with a rational or irrational number. Immediately we can conclude that it is non-terminating, and so we must look to see if there is a discernible pattern within the decimal portion of the number. And once again, there is not a discernible pattern. And so we have another non-terminating, non-repeating number, meaning that the resulting product is once again irrational. And so we can conclude that the product of a rational and irrational number will assume the properties of the irrational number. Now, why is this? Well, the first reason is that the closure property applies to multiplication and results in a number categorized or classified. Let's use classified because that's what the terminology we're working with. Classified in the same set of real numbers. And immediately you may think, wait a minute, rational and irrational numbers are not in the same set of real numbers. And that is true. They are classified differently. However, both rational and irrational numbers are classified as real numbers. They are both in the set of real numbers. So what we're actually doing is multiplying a real number. So we are multiplying a real number times another real number. Okay, so real number times a real number, and actually I'm going to rewrite that to make it a little nicer. Let's do this. Let's do it this way. So we have a real number times a real number. So a real number times a real number will result in another real number. And so the closure property holds for multiplication and results in a real number. Now, what properties will this real number assume? Well, part two is, or reason number two, is the resulting product will assume the properties of the non-terminating, non-repeating set of real numbers. So it's going to assume the properties of the non-terminating, non-repeating set of real numbers, meaning it's going to assume the properties of irrational numbers. And once we consider why this might be, if we were to, or when we think about attempting to multiply a number that terminates or repeats, and in this case, we will work with the 6.25. If we look at that 0.25 portion, and we attempt to multiply that by something that does not terminate and does not repeat, there is not a method, or there is not a way that we can cause this portion that I've highlighted in yellow, for example, in pi, there is not a way that we can cause that to terminate or repeat using a decimal that is being multiplied with that either terminates or repeats. So let me rephrase that. So using a number or a rational number that terminates or repeats, such as 6.25, there is not a way for us to cause the non-terminating, non-repeating portion of an irrational number, such as the yellow highlighted portion of pi in decimal form. There is not a way for us to cause that to be truncated or changed to become either terminating or repeating. And so the properties of the non-terminating, non-repeating portion of the decimal of an irrational number carry over and carry through to the resulting product, which results in an irrational number. So when a rational and an irrational number are multiplied, the result is contained within the set of all real numbers and assumes the properties of the irrational set of numbers.